Hello, I'm JW. This time I'm going to have a look at equipment classes. And again, this is something you may have seen on various bits of equipment before, particularly Class 1 and Class 2. Class 2 also known as double insulated. And those are actually the most common ones, 1 and 2, but there is also a 0 and a 3 as well. So we'll have a look at those, see what they actually refer to. And this is only applicable to electrical equipment. It's not something you would normally apply to an installation or the fixed wiring, whatever. It's just generally applied to manufactured items, and that's generally where you'll see these things. Now these apply to, say, equipment, but it's useful to know these because, of course, when you're installing things like light fittings or other pieces of electrical equipment, it's necessary to know the actual class of equipment so that you connect it correctly. And the most common, as I said there, were Class 1 and Class 2, although there is also a Class 0 and there is a Class 3 as well. However, 0 should not really exist anymore because it was removed and discouraged a very long time ago. Class 3 does exist, but it's not generally things you're going to be installing into the electric installation. Generally 2 and 1 are the usual choices. Now, all of these things are defined in another standard, and the particular standard in this particular case is 61140. If you want to go and buy that, then you can. It's BSEN 61140, and as with all these things, it's surprisingly expensive, but we're not going to necessarily go through the entire thing. We'll just cover what the various classes actually mean and the implications for when you're installing them. So let's have a look then. So Class 0, this one you really shouldn't find anymore because it was discouraged and deleted a very long time ago. Class 0 is defined in the standard as equipment with basic insulation as provision for basic protection and no provisions for fault protection. So essentially what you're going to have there is you're going to have your live conductor, so there's that your copper core of the cable. On the outside you're going to have the insulation, let's just draw in black here, just a single layer of insulation there, so not the case of a flex with 2 layers, just a single layer of insulation, and that's it. So there's absolutely nothing else. And as you can see why this is not really used anymore. The only thing which was available once were the old type Christmas tree lights. And those are basically exactly what we've got here, just a single insulated piece of wire. It come along, goes into the first light like that, goes to the next one and the second one, and so on. And then when it gets to the end of the generous set of 20 of those, the wire goes back to the supply. You shove 240 volts AC in there, and because you've got 20 of the lamps, each one is basically a 12 volt AC lamp, and they're all wired in series. And this also means that when one breaks, the entire set fails and you have to then stumble through and attempt to find the broken one. But of course nobody makes these anymore, haven't been made for decades, but there may still be a few old sets hanging around somewhere. That's a Class 0. So single insulation, so any damage to this conductor anywhere is going to expose the inner core. People get a shock from it. Definitely not recommended. They did improve these eventually towards the end of the era, and they made these in what's called permanent contact lamps, so that if the lamp did fail, it basically shorted out inside, which then maintained the connection through. The problem then was that the 240 volts isn't divided by 20, making 12. It's divided by however many are left. As the lamps pop off and break, voltage across each one increases, and then the current increases exponentially, and once it gets to a certain number, the whole lot goes up in a ball of flaming wreckage, assuming you of course hadn't got the fuse lamp in, which most people replaced with a standard one because they couldn't be bothered to buy the special fuse variety. But that's all in the past and has long gone. Class O's or Class Zeros are pretty much not a thing anymore. So we'll move on to Class 1, which is certainly rather more common, and this one is defined as equipment with basic insulation as provision for basic protection. That's pretty much what we had there with the single insulation over the live conductors, and protective bonding as provision for fault protection. Now that description isn't particularly helpful, and using protective bonding there isn't particularly helpful either, but essentially what we're meaning is that you've got your conductors inside the equipment and they're going to have a layer of insulation over them. I'll just draw that in black there. Again, it's only a single layer of insulation, so it's just a wire with PVC or whatever over the outside. But the important difference here is that these things are going to be enclosed in some kind of equipment. We'll just draw that in brown here. And crucially, the outside of this is conductive, which generally means, of course, it's made of metal. And what is going on about protective bonding is that the metal case will be connected to the protective conductor of the circuit, or basically the earth of the installation, also shown as that symbol like that. Now the idea with this is that single insulation is there as the sort of basic protection there. If this becomes damaged, then rather than someone getting in contact with it, this could come into contact with the metal case of the equipment. Because it's connected to the earthing of the installation, gives it a very low impedance path there, so a large amount of current is going to flow here, and that's when your circuit breaker will trip or the fuse will blow, disconnecting the supply and making it safe. So that's a very common item, particularly on things like kitchen appliances, sort of washing machines, ovens, cookers, that sort of thing, electric kettles. And that's mainly because most of those things have large metal cases around the outside, which of course are connected to the earthing of the installation. So we've got a class 1 item. It will most definitely have that connection there, and it is absolutely essential that it is connected to the earthing of the installation, and also confirm that it's connected properly and the socket or attachment to the installation wiring is actually connected to that. And of course you need to test that when installing the equipment. Possible danger with these things is that if this conductor here was damaged or not connected or broken in some way, what happens then is that if a fault occurs inside and the conductor comes into contact with the metal casing, no current flows here because of course that connection's gone away. Instead, the whole of the metal casing becomes live at 230 volts AC, and it just sits there until some poor person grabs hold of it, and then that person becomes the path to earth. Current flows through the person's body and causes serious injury or death. So that is why anything that's a metal case that is required to be connected to the installation earth, absolutely essential that it's done correctly and that it is tested every time. Otherwise it's going to cause an extremely dangerous situation if a problem occurs inside the equipment. So it's not that the metal case is some kind of safety device. It's put there and then we need to connect it to the earth, simply because if we didn't, it would actually create a huge electrical hazard there, shocking people and causing injury. Now class 2 is defined as equipment with basic insulation as provision for basic protection, so that's exactly what I had before, just that insulation over the live parts, and supplementary insulation as provision for fault protection, or in which basic and fault protection are provided by reinforced insulation. So live conductor inside, it's going to have insulation over that one, so just in your normal insulated wires or whatever else. And then additionally over that it's going to have some kind of additional insulation, so either supplementary insulation or reinforced insulation. The most common arrangement of this is that the outside of the equipment is made of some kind of insulating material, usually some form of plastic. So in this case you've got 2 layers of insulation. This is really where this double square thing comes from, representing the 2 layers of insulation between the conductor inside and the outside environment. The idea with this one is very simple. Got the conductors inside there. If this insulation should become damaged inside or something happened in there, this live part could come out. But if it contacts the outer casing or the second layer, nothing actually happens because of course this is an insulator. So again, nothing happens, no one gets injured or shocked from it. So the only way to get a shock from a class 2 item is if both the inside insulation on there and the outside was somehow damaged, and then the wires are exposed or conductive parts are exposed. That's not impossible, but of course it's extremely unlikely. You generally have to smash the thing apart and cause extensive damage to it to actually get into that kind of state. So generally it's things with a plastic outer casing, and if you have to look around your house or anywhere, office or wherever you are at the moment, you'll see that the vast majority of equipment is actually going to be in this class, simply because most things are now made of plastic. One key point about these is that there is no connection to the protective earth of the installation, so it just simply isn't a thing. There will typically only be 2 cores in the conductor flex coming from the appliance, those being of course line and neutral. They don't actually have anywhere to connect the protective conductor or the earth of the installation, and you shouldn't attempt to connect things to it either. In terms of the fixed wiring, you will still have that protective conductor up to the point where it's connected. If it was, say, light fitting or whatever, that would still be there. You would just put that in its separate insulated terminal, not actually connected to any part of the light. And of course, if it was something that plugs in, it's going to have a 3-pin socket to plug in on the wall. The plug will either have a plastic earth pin on it, or in some cases it's a metal pin which simply isn't connected, usually found on those moulded on plug type things. Now, so this is very, very common on all kinds of equipment, but there are a couple of areas to be aware of here. Just because something is made of metal doesn't necessarily mean that it's a class 1. There are a lot of metal items which can be a class 2, and likewise, just because something has a plastic outer casing doesn't necessarily mean that it's class 2, because it could be a class 1. Now, one thing to look out for particularly on class 2 are cooker hoods, also known as range extractors and things in other countries. Basically, it's the deal that goes above the stove or range or cooker or whatever, and there's a big fan inside, and you turn it on and it sucks all the cooking fumes away outside. Now, most of the ones sold in the UK are made of steel, usually stainless steel, those things that stick up on the wall and collect grease. However, despite the fact that the outside is made of steel, most of them are actually class 2, because the outer steel isn't connected or anywhere near any of the electrical components, because what's inside is generally a big fan, sort of a motor type of arrangement, and then the cable is a 2-core. It just goes inside and then comes out into the outer steel covering. This flex or cable will be double insulated. It's going to have the 2 cores insulated inside and then a further layer of insulation over the top. This casing for the fan is almost always plastic, but around the outside of it there's quite often a steel or metal canopy type shaped thing. But if you actually test this, there's no connection between the metal parts and any of the internal parts, and there won't be an earth connection on this either. And most importantly, you do not connect the outside of one of these things to the earth connection, because that would actually make it worse than you would actually have in the first place. Bearing in mind, if you've got a double insulated appliance, all of the live parts are enclosed within at least 2 layers of insulation. Extremely unlikely that they're going to be breaking through all of that and getting to the outside. So the outside metal bit is just sitting there, it's not connected to anything, it's not effectively even part of the electrical installation. If you then decided for some reason to connect the protective conductor to the metal casing, what you then got is a huge big slab of metal which is now connected to the electrical earth, which isn't really desirable, because if someone grabs hold of that and touches something else like a class 1 appliance, there's a fault in that one. You've now got a nice handy path to earth through somebody's body, holding one in each hand, so you've actually made that situation worse. So key thing with class 2 items, there is no connection to earth or the protective conductor, and you shouldn't attempt to add one, because in most cases that will make it worse. So when you're installing these things, don't assume that metal means class 1. Have a look for the symbol there, check in the manufacturer's instructions, because it will specify what class it is and of course how it's going to be connected. In terms of class 1s which are made of plastic, the most common example of these is a kettle. Kettle in this case meaning a thing in the UK where you put water in it and boil it up to make a cup of tea. Now, lots of kettles have a metal exterior, even more of course have plastic exteriors, but the vast majority of kettles are class 1, even though they may have plastic on the outside. And in fact, even some of the metal ones are class 1, but they're not necessarily class 1 in the way you might expect. So if we just draw a typical kettle here, what's going to be inside the kettle is going to be some kind of heating element, and then the outside body of the kettle goes around it. 2 conductors coming in, so that's going to be your line and neutral, which go basically to the heating element there. The class 1 part of it is not usually the outside casing in the kettle, as in the bit that holds the water. That can be made of metal or plastic, but if you get a metal kettle, you quite often find that the metal body of it is not connected to the protective conductor within the flex. So if you test between the earth pin on the plug and the metal body of the kettle, you'll probably find there's no connection there. You might think, well, something's gone wrong, it's faulty. But actually, no. The protective part is actually the metal casing that goes around the heating element. And of course, it's on the inside as well. So the idea there is that inside there is your live conductor. On the outside is the metal casing completely surrounding it, and it's also waterproof, of course. That is connected to the earth pin in the plug there, so that if the element fails, the wire inside could contact the metal part of it. That's where you get your huge current flowing, trips the circuit breaker, or blows the fuse. And the same applies to most plastic kettles. Although the whole kettle is actually plastic, inside it's going to have that steel cased element. So again, if a problem occurs with that, it causes the same effect, so it disconnects the supply from doing that. So if you're going to test a kettle, just beware that you're not testing to the outer covering. In most cases, actually the outer casing of the element. And in a lot of kettles, you can't actually get to that anymore because they have these sort of flush bases inside to make it easier to clean. So Class 1 will have this arrangement, but it's not necessarily the outside metal casing. Class 2 has plastic double insulation in it somewhere, but again, it may have a metal outer decorative part, which is not part of the equipment. So again, always check the instructions and definitely look for the appropriate symbols on each. Now the final one is Class 3. These are relatively common, but they're not normally the sort of thing you're going to be installing within a fixed installation, although it's certainly not impossible. And Class 3 is defined as equipment relying on limitation of voltage to ELV values as provision for base protection and with no provision for fault protection. So essentially this means that it works on voltages up to 50 volts AC or 120 volts DC. And the most common example of this is, say, a computer or a phone or tablet or something like that, where the actual connection to the main supply, the 230 volts in the wall, is some kind of power adapter. The actual thing itself runs on a much lower voltage, thing to plug into USB outlets, that type of thing. So there isn't any sort of fault protection in such, because it's limited by the fact that the voltage is very low. Therefore, even if someone came into contact with it, it's not going to cause a problem. USB things are particularly very common. Those actually only work at around 5 volts DC, in some cases more, and a lot of computers and things like that are also in this category. Easily identified by the fact that the connection to the power is going to be via some kind of power block or some kind of conversion device. 230 volt AC goes in one end, and some other voltage lower than 50 volts AC or 120 volts DC comes out the other side. Most commonly found, say, on portable equipment. It can be in things that you're going to be installing, say things like LED tape, for example, would be a Class 3 item because it has the actual power supply or the power converter unit, and then the tape itself runs at some low voltage of DC. The actual 230 volts gets nowhere near it, and it's separated from that, and therefore there's not a problem. Even if someone came into contact with it, it's not going to cause a shock or any kind of injury. And just as with the Class 2, Class 3 equipment does not have any connection to the protective conductor. It's a completely separated and independent system. Effectively, sort of, you could run it off a battery or something like that as well. There is a symbol for that one, which is essentially the number 3, and that's sort of Roman numerals thing, and that's actually put within a diamond, something like that. You may see that on certain bits of equipment. And as I saw previously, the others have the Class 2 as the 2 squares, and the Class 1 will have the earthing symbol, or should do, on the equipment itself. And Class 0 doesn't have a symbol, mainly because it shouldn't actually exist anymore. So that's appliance classes. Say 1 and 2 are by far the most common, 1 being the ones that have the protective conductor connected to a metal part. 2 does not, and it's very important to realise that you do not connect the earth connector to any Class 2 equipment, because in doing so you can actually increase the risk rather than reduce it. And the other thing with particularly lighting equipment is if it is marked up as a Class 2, that only applies when it's installed according to the manufacturer's instructions. So if you get one of those despicable things from a certain DIY store, and in the top of it there's the 2 wires going into that little tiny white plastic block, which only has room for conductors of the smallest size and only 2 of them, then in theory what you're supposed to do is to fit those conductors within that, and there's that little black insulating sleeve and it's all carefully contained within. If you don't use that and use something else, then of course you're not installing it to the instructions, and the Class 2 thing doesn't apply anymore. So don't be tempted to, say, shove a load of those sort of Wago connectors or whatever in the base of the usually metal light fitting and not use the plastic thing, because of course then it's not Class 2 anymore. If you do get one of those, the proper thing to do is to put the other conductors, which inevitably there will be some, into a separate junction box in the ceiling. Out of the ceiling, you've just got a 2-core flex, which then goes into the light fittings connector, and that maintains the Class 2 rating of the equipment. And then, of course, there's those cheapo ones that are imported from other parts, which may not comply with any standard, even though they might claim it. So just buy things from reputable suppliers and follow the instructions. So that's it for this video. Until next time, thanks for watching.